Okay, pretend this is a meter stick. So we started at positive, we went to the left, our speed was increasing, so the velocity is negative because we're going to the left, we're speeding up. Now here's the position versus time graph. Now you notice, well, I started at rest. So right here, what's the slope? It's 0. And then what happens to the slope? Now, you have to be careful. The velocity is negative because the velocity is a vector. Velocity has magnitude and direction. But what's the magnitude of velocity? It's speed, which is a scalar. So all I care about right now is the speed. In other words, the absolute value or the magnitude of the slope. So here the slope is 0. Now what happens to the absolute value of the slope? It gets larger and larger and larger and larger and larger. So that indicates that the speed increases. So it's all about slopes, right? The velocity is the slope of a position versus time graph. That's the important thing. All right, this is a really good question. So after I'm done, so read it, figure it out, pause your video. Okay, we're back. All right, now these are position versus time graphs. Okay, don't need this anymore. So a person initially at point Q. So we start out at a positive position, right? So we know right away that this is wrong because it starts out at a negative position. This is wrong, it starts out at 0. All right, so it could be that or that or that or that. All right, so we start out at P and we stay there for a moment. So that means the velocity is 0. So 0, 0, 0, 0. And then, let's see, and then we move along the axis to Q. So we start at P, then we go to Q. Well, that's in the negative direction. So that means that the velocity has to be negative, so the slope has to be negative. So that's negative, that's negative, that's negative, that's negative. But we want to move from P to Q. Now notice Q is a positive location, right? It's at 1, right? Well, this goes to 0, so that's wrong. Okay, this is okay. This is wrong because it goes to a negative position. This is okay. All right, so now so it's either this one or this one. All right, so we move to Q, then we stay there for a moment. Okay, that's fine. That's fine. And then we run quickly to R. So we're at Q, we run quickly to R. All right, so compare this slope with this slope. Which is the larger slope? This one. But let's just keep going. So it looks like this is correct, but let's just keep going. So we run quickly to R, stay there a moment, stay there a moment, stay there a moment. And then we stroll, which means walk super slowly, stroll slowly back to P. So we're at R, then we go back to P, so we're moving positive. So this is kind of small velocity compared to this one, right? Or small speed compared to here. But here, this is a larger speed compared to here. So this is the answer. Make sure you understand that. All right. Here, this is a velocity versus time graph. So, and here, again, velocity delta x over delta t. So what I want you to do, please, is draw a position versus time graph. So now we're going backwards, right? Before we had a position versus time and we figured out the velocity. Now I'm showing you the velocity versus time, and I want you to draw the position versus time. So pause your video and figure that out. And it's not easy, especially here. So think carefully and you know, use your ruler, right? Think of slopes, okay? Use this equation and think of slopes. All right, we're back. Okay. here, the velocity is positive and constant. So that means I have to have a straight line, the slope is constant, and it has to be in the positive, has to be positive. Okay, let's do this. Here the velocity is negative and constant. So I have to have a straight line with a negative slope and a constant negative slope. Here's the tricky part. So here, what's happening to velocity? Well, let's just talk about, well, whatever. Okay, what's happening to velocity? It's getting smaller and smaller and smaller. Here the velocity is 0, and then the velocity starts getting negative. All right? Okay, so here we go. Right here, and again, the velocity is the slope of the position versus time. So here, what's happening to the slope? It's getting smaller and smaller and smaller. Right here, the velocity is 0. If the velocity is 0, that means the slope is 0. So right here, the slope is 0. Okay, then what happens? Then the slope starts getting what? The speed gets bigger and bigger and bigger, right? The absolute value of the slope gets bigger and bigger and bigger. But the slope in here is negative. All right, so the speed gets bigger and bigger and bigger, but it's negative, so its velocity is negative. Make sure you understand that. All right, so again, what's happening? The object is going at constant speed, then slows down, stops, then all right, constant speed to the right, still moves to the right, moves to the right. Now, sorry, this is negative velocity, and this is 0, and so forth. Okay. All right, new subject. Now what we want to do is we want to find the position from the velocity and from the time. So in other words, if somebody tells us the velocity and the time, we want to find delta x, how far the person or whatever the object has gone. And we'll do two cases. We'll do the easy case first, which is constant velocity. Then we'll do the difficult case. Now, you already know this with constant velocity. If you run at 10 meters per second for 10 seconds, what's your new position? Well, 10 meters per second times 10 seconds, that's 100 meters. So your delta x would be 100 meters. Okay, so like I said, you already know that. But let's do it mathematically. Okay, mathematically, you have some initial point, then you move, then you end up at some final point. I mean, no kidding. All right, now, here's the question, though. What is delta x in terms of the velocity and the time? Well, you all know this. Distance equals speed times time. Distance equals speed times time. So delta x is just v delta t. And again, we're saying that the velocity is constant for this situation. All right? Okay, so we can say that x initial plus v delta t equals x final. Now, I want to change it just because another way to say that is x final equals x initial plus v delta t. Okay? All right. Now, again, this makes sense, right? You start somewhere, you move for a certain amount of time, and by golly, end up somewhere else. So that just sort of agrees with common sense. We're going to use this equation again, so all right, it's kind of a big deal. And again, let's go back to my example. You know, I said if you run at 10 meters per second for 10 seconds, you run 100 meters. So x initial would be 0. Velocity 10 meters per second times 10 seconds is 100 meters. Now look at the units. Look at the units. 10 meters per second times 10 seconds. The seconds cancel, and you get 100 meters. That's what I was talking about in Chapter 1, how you treat those units as algebraic quantities. Okay, now, this is a velocity versus time graph. Okay, velocity versus time graph. So what is this v delta t? What on the velocity versus time graph, what is this v delta t? Well, this is v, right? This is delta t. So it's just this area. It's just the area. And you know this from your math classes. We call it the area under the curve. The area under the curve. And what does it represent? Well, I already told you, right? V delta t represents the change in position. The change in position. And again, look at the units. Meters per second, right? Velocity meters per second times time in seconds. Meters per second times seconds is meters. Just like I showed you there. Okay? All right, so figure that out. So pause your, figure that out. Pause your video, figure it out. All right, let's do it. So x final equals x initial plus v delta t. All right, it says x initial is 10 meters. Just leave it, sorry. 10 meters. And then the velocity is negative. That means we go backwards, right? So it's negative 2 meters per second. The time, 2 seconds. Seconds cancel. Negative 2 times 2 is minus 4 meters. So you have 10 meters minus 4 meters, which is 6 meters. Okay? And again, just think about it. If you start at 10 meters per second, you start somewhere over here at 10 meters per second, and then you go to the left at 2 meters per second for 2 seconds, that means you move to the left 4 meters. So if you start out at 10, you move 4 to the left, you're at 6. Okay, so that's not so bad. Now we'll do the bad one. So this was easy because we had constant velocity. Now what we want to do is we want to have changing velocity. So here's the velocity graph, right? So the velocity is changing crazy, right? I mean, the velocity is certainly not constant. Okay, well, this equation is still true. We just have to modify it. Well, we have to reinterpret it, okay? I said earlier that this v delta t is the area under the curve. That was just a rectangle for constant velocity. Well, if we have something crazy like that, I mean, this is still the area under the curve, but obviously it's not going to be a rectangle, right? It's not going to be a rectangle. So there. So that's the area under the curve. All right? Okay, kind of messy, but you can do it. In lab, you'll do it, and the computer will calculate the area under the curve. So you'll see this again. All right, here is a wonderful example. So this is, again, velocity versus time. Is the velocity constant? Certainly not. The velocity is increasing, right? We start at 0, and it increases. Oh, boy. Okay, now they tell us that the velocity is 4t in meters per second. Now, why is that? Well, let's do it. Okay, so this is a straight line. So as you learned a long time ago, equation of a straight line, y equals mx plus b, right? M is the slope, b is the y-intercept. But what we have here, we have velocity equals a slope. The x is the t, right? So, okay, that's what we have here, right? Velocity equals the slope times time plus b. Now, what's the y-intercept? 0. Well, that's nice. Okay, now what's the slope? What is the slope? Well, pick this point, pick this point. So the slope, again, it's the rise over the run. So from here to here, so it's 12 meters per second. 12 meters per second. And then the time from here to here is 3 seconds. So it's 3 seconds. So 12 over 3 is 4. Look at the units. Look at the units. What? Oh, okay. Well, all right. So the slope is 4, right? 4 meters per second. 4 meters per second divided by a second is 4 meters per second squared times time. So we can just write that as 4t, okay? And its velocity, you know, time is in seconds, so it's going to kill one of these seconds, so it's going to be in meters per second. Okay, make sure you can do that. All right, now, where'd it go? Okay, so I want you to do this. So as soon as I'm done talking, pause your video, find the final position. Assume the initial position is 0, and assume the final time as shown is 3 seconds. So use this, where this is the area under the curve. So pause your video and you figure it out. And don't cheat, all right? You figure it out. You can do it. All right, let's do it. Okay, x initial is 0. That was given. And this is the area under the curve. Well, this is a triangle. What's the area of a triangle? 1/2 base times height. So we have 1/2. Okay, the base, and always use your units. Get in the habit. The base is 3 seconds. And what's the height? The height is 12 meters per second. So half of 12 is 6. 6 times 3 is 18. And look at the units. That goes with that. So we just get 18 meters. So that's the answer, right? 18 meters. Make sure you can do that. Okay, new topic. Again, this is a position versus time graph. Position versus time graph. Now, here's a straight line. Okay, well, sorry. Here's the motion of the object, right? Okay. But for whatever reason, oh, and then down here. Whatever reason, I just want to draw a straight line here. Now, you should know, okay, so what's the approximate slope of that straight line? Just figure that out, please. So pause your video, figure it out. Just approximately, don't get super picky. So, all right, so let's do it. So the change in y, okay, so we're going to go from this point to this point. So that's at positive 200, that's at negative 200, right? Okay, so 200, okay, so the slope, 200 meters minus a minus 200 meters is 400 meters. And then the time, 16 minutes ago. 16 minutes minus 0 minutes. So that's 16 minutes, all right? So 400 over 16 is 25, right? So that's 25 meters per minute, okay? All right, so what is that? You know, I mean, it's a delta x over a delta t, right? But I didn't care about all these, you know, I didn't care about when the velocity changed. So what does this 25 meters a minute, what does that represent? It's the average velocity. We talked about that last time. Average velocity, okay? Average velocity, the total displacement over the time. All right, super. All right, so what is this? Describe the motion from 2 to whatever that is, 5 or something like that. Here, what kind of motion is that? Well, it's a straight line, constant slope. So this is uniform motion. The velocity is constant. Velocity is constant. And again, it's the slope, right? I mean, right? Slope. So here, the slope is constant. Velocity is constant. Uniform motion. How about there? Is that uniform motion? Certainly not, right? The slope varies all over the place, right? So that's, okay, if this is a uniform motion, what are we going to call that? Non-uniform motion, right? Non-uniform motion. What is the slope, just approximately now, what is the slope at this one particular time? So hopefully you learned that in your math class. How do you find the slope at a point? You find the slope of the tangent line. The tangent line. So this angle is the same as that angle. Tangent line. So let me draw that, or let me show you that. Close enough, right? Okay, so we want to find the slope of this line. So figure that out, please. Pause your video and figure it out. Okay, so I went from this point to this point. So the velocity, again, delta x over delta t. So delta x is 1,000, right? 1,000 meters. And from here to here, I don't know, it's 15, that's like 9. So 15 minus 9 is 6, right? Wait a minute. Oh, this is like, oh, I'll call that 16. So 16 to 9 is 7. We're just doing approximately 7 minutes. So that's 143 meters per minute. Okay? Now, remember, the slope of this line, that was the average velocity. So what do you suppose, what is the velocity at a particular point? Well, that's called the instantaneous velocity. The instantaneous velocity. So from now on, whenever I use the word velocity, I always mean instantaneous velocity. Instantaneous velocity. What does your speedometer in your car measure? Average or instantaneous? I'm assuming you have a new car and your meter gives you the speed and the direction, okay? All right, so what does it measure? Instantaneous velocity or average velocity? Instantaneous, right? Instantaneous. Okay, a couple questions for you. Okay, so read that, figure it out. So read it, pause your video, figure it out. Okay, let's do it. So a car moves, this is a position, first of all, you always have to ask yourself, what kind of graph? It's a position versus time. So what's important here is the slope. The slope is the velocity. So a car moves along a long, straight track. The graph shows the position versus time. The graph shows that the train does what? Okay, it's all slopes. So what happens to the slope? The slope gets smaller and smaller and smaller. Also, hold it. What's the sign of the slope? Is it positive or is it negative? It's positive. Okay, so we know that the train is going in the positive direction, but it's slowing down. Okay? It slows down all the time because the slope is always getting less and less and less and less. Okay, here's another one. So pause your video and figure it out. All right, we're back. So the graph shows a position versus time graph. Two trains, parallel tracks. What is true? So let's actually go, well, All right, let's just go through them. All right, at time tb, both trains have the same velocity. That's garbage. Remember, velocity is the slope. The slope of A is here, the slope of B is there. So A is totally wrong. 2, both trains speed up all the time. Well, let's see. Let's see. This guy is slowing down, and this guy has a constant slope. So number 2 is wrong. Okay, 4, we don't even know what acceleration is yet. We haven't even talked about it, so we know that's wrong. Has to be 3, right? Both trains have the same velocity at some time before TB. And that's true, right? Somewhere around, I don't know, around sometime here, right? Because, so look at, here's the slope of this guy, and here, like right around here, that's the slope. So don't these have the same slope? Yeah. So the answer is 3. All right. So all we've done so far is talk about position and velocity. Well, what we're going to talk about in the next video is what happens when the velocity is changing. Okay, let's quit.